Thank you for joining the panel discussion. We will discuss about the land, water, energy, biodiversity, nexus. So as you know that our world is connected directly, indirectly as nexus, and that is connectivity not only among the resources such as water, energy, food, but also land and biodiversity. And also this connection is occurred among the society, economy, and environment as SDGs, and the local and global. So today it's a panel discussion talking about how the land, water, energy, biodiversity are connected as nexus. We will have 5 panelists from each country, and then we will have a discussion after that. Each panel have a 10 minutes talk, and I'm very happy to invite first panelist. The first panelist will be Suzanne Hanger-Kopp. She's the awardee of the 2021 IIASA Strategic Initiatives Program, and she's a research scholar at the Equity and Justice Research Group. So Suzanne, when you are ready, please go ahead.
Yes, I hope you can see my screen. Just the presentation. Perfect. Well, good morning, everyone. Good afternoon. And thank you for inviting me to be a part of this panel. I indeed have been awarded a grant to do exciting Nexus research in Asia. We just started this project, so I really would like to make you curious about our work and to get you interested in what we're doing. So I will just give you an overview of what this project does and also link it to other Nexus research that we have done at IIASA. And I hope this will give us the chance then in the future also to stay connected via this interesting topic that we are treating in Asia. Let me start saying I'm not an expert on Asia myself, at least not yet. And I've never explicitly worked on Nexus issues until recently. And I'm saying explicitly because when you do work on drought and water stress, which I did, you are inevitably operating at a Nexus, right? So no matter what you call it, really. Even though the Nexus issues in Europe are probably quite different than those elsewhere, such as in Asia. But both topics, drought and water stress, which are in many instances the same, are obviously at the intersection of policy fields that manage essential resources that are subject to social and environmental drivers, sometimes synergistic and sometimes conflicting. So this is sort of what we operate as our Nexus definition. And today I would like to briefly introduce the project that will finally give me the chance to work in Asia and to work explicitly on a Nexus topic. But I also would like to assure you that I'm not without support. So there is obviously a lot of expertise on Asia at IIASA and also on working on Nexus issues. I put some of my colleagues up there who will help me in this project, or who I'm cooperating with in this project. And they have done exciting work, for example, on the Israel project, which some of you might have heard of, which was the first and really impressive Nexus project at IIASA that has done global assessment of Nexus hotspots, really, and created impressive tools also for searching for high impact areas in terms of Nexus challenges. But what they've also done based on this, and what's the next most important step, is going directly into specific areas, right? Because Nexus issues are obviously very specific to certain areas. And they went into 2 river basins, one in Africa, the Zambezi, and one in Asia, the Indus, where they generated comprehensive knowledge on Nexus issues together with stakeholders engaged in basin management. So still at a fairly high level. But you can imagine that as being innovative tools such as, you can see here in this picture, as serious games that can bring the Nexus issues actually to life, which the colorful map does not. And so they really help you to make visible the practical implications that the Nexus issues have on the ground and for decision making. So this is really crucial to understand and to create a shared understanding of actual Nexus challenges and also to the solutions at hand. And only in this way you can actually generate the kind of ownership that it needs to implement those solutions as well. So another project that we're also linking to, and even much more heavier than the Israel project, is the FUSE project that is still being finished up, and that project also operates at the water, food, and energy nexus, but it already highlights, slightly different than Israel, more explicitly the context of conflicting driving forces around nexus issues that Professor Makoto also already mentioned, right? So there's different pressures that we need to think of. And what they did in the Bhima Basin in India was that together with stakeholders, they really explored what are the specific driving forces in the certain case, and identified over 18 nexus challenges, such as increasing regional water scarcity and drought risk, inefficient water and energy distribution and pricing schemes, but also the loss of agricultural land to do urbanization and energy cropping. And all this fed into a simulation model to determine the outcome of different pathways that the case region might take, and to find a better way of again, same in the Israel project, to generate ownership for the pathways and the solutions that need to be implemented on the ground. So Israel and FUSE have in common that both projects are modeling heavy, and the stakeholder engagement, although it was excellently carried out, was rather the add-on to the modeling work. And we believe in Fairstream that this puts constraints on the type of knowledge that can be produced with stakeholders and the extent to which ownership can be created. Sometimes that's okay and even necessary, but it's not in the spirit of what today is trending as transdisciplinary research. Moreover, both projects, such as most Nexus work, only implicitly, if at all, address biodiversity. So they sometimes see it as an external driving force, as part of environmental pressures, for example, but it often doesn't really end up modeled or discussed in such an integrated assessment explicitly. So at the same time, biodiversity plays an essential role underlying a lot of Nexus problems. Again, I'm repeating what Professor Makoto said. And finally, what these problems sort of talk about, but what also remains implied, are the ideas of justice that are underlying a lot of these Nexus issues, right? Nexus issues are always about tensions between distributive outcomes in one way or another, and sometimes also in terms of procedure. And that's where Fairstream comes in. So in Fairstream, we look at the food, water, and biodiversity nexus. We decided to leave energy a bit to the side simply for the sake of scope, but really try to look into the biodiversity aspect of things. We will not start with the model, but with the stakeholders, and aim to convene a wide variety of actors and jointly generate new knowledge, enable mutual learning, and that across not only the science and policy interface, but the science, policy, and society interface. And that's what's often referred to as co-production. Just to give you finally a good definition, because the term co-production for stakeholder engagement has been all over the place. It's an iterative and collaborative process involving diverse types of expertise, knowledge, and actors to produce context-specific knowledge and pathways towards a sustainable future. So we will also look at the fairness implications, procedural and distributive. And finally, we upscale the findings from those co-production processes for more realistic kind of modeling that we believe is needed. So we will do large-scale agent-based models, and we believe that's our best option to accurately simulate the actual system's dynamics. So this is what we're going to try, but the model comes sort of third only. So we will test our methods and model in the Bhima Basin in India, building on the processes and insights created in the FUSE project. So we really want to, not reproduce stuff, but continue the work that has been started. Bhima Basin is a highly managed river basin in Western India, for those who don't know, with important urban centers, intensively farmed hinterlands, and biodiversity hotspots. So we know some of the challenges from FUSE, and that will enable us to focus really on the role of biodiversity in that particular case. Sorry. So a good co-production process requires methods tailored to the problem in hand and the stakeholders involved. And we are experts already in several of these methods, but we have not yet developed them to a level where they explicitly account for the dimensions of fairness and where they have fully unfolded their ability as systems analytical methods. And that's what we want to do. So we will build on work started in the EQ group and review established co-production methods and look as to whether they are suited to assess ideas of fairness. For example, we will develop process blueprints for co-production to adhere to procedural justice principles. We will redesign methods in a way that they include principles of distribution explicitly. And in the second step, we will then bring in the systems dimensions in these, or bring out the systems dimensions in these co-production methods. So we will work our way back from the literature and system thinking and define and categorize the key elements of systems methods to add and enhance these elements in the respective co-production methods. We believe that these improvements are crucial for Nexus research to remain policy relevant. But as I said, to make an even more important contribution, we explore the potential for agent-based models to simulate and upscale co-produced data. And together with select stakeholders, we will quantify the storylines coming out of the co-production processes in the Bima Basin. That will generate input for an agent-based model. And that will then simulate millions of individual and heterogeneous farmers, as well as other stakeholders at a high resolution. Moreover, to simulate the interactions with the environment, the ABM will dynamically be coupled with state-of-the-art hydrological models and biodiversity modules, but that only after we find out with the stakeholders what the actual problems at hand are, so we can, tailor the model as much as possible to those needs. By running this integrated model, we will then investigate small and large scale effects of individual and collective ideas of fairness and preferences for regional development in the Bima Basin. And that's really what we are going to do. Maybe I can summarize a little bit. We will integrate the biodiversity in the Nexus approach. We will highlight questions of fairness that underlie most of these Nexus decision problems, but particularly those related to transformative sustainable development. We look at developing and streamlining co-production methods as crucial systems and analytical tools, and we will create upscaling methods for co-produced data by means of open source, large-scale coupled agent-based models. And those we will then again increase the number of sectoral models that can unravel synergies and trade-offs for Nexus issues. And our vision really is, as I said, to build in this existing co-production process in the Bima region and hopefully stay there beyond this one project, right? To continue work on Nexus issues at a long-term scale. And not only obviously in this one case that we have started, but we are glad to say that already colleagues in South Korea have announced interest, and also colleagues in China have announced interest, and are setting up processes so we can establish case studies local case studies for co-producing Nexus knowledge all over Asia, hopefully. Thank you very much for your attention.
All right, thank you, Suzanne. That's great talk. And that's good to know about the co-production and system analysis as well as fairness. And I will ask audience, if you have a question, please write in the chat box and we can ask each presenter to answer to that question. So I'd like to move on to the next panel. I'm happy to invite the second panel, Jungwo Liu. He's a chair professor at Southern University of the Science and Technology in China. So Professor Liu, please go ahead.
Hello, here?
Yes, please go ahead.
Okay, thank you. It's a great pleasure to give a presentation here. I'm a chair professor from Southern University of Science and Technology, but at the same time, I'm also a visiting senior research scholar of IIASA. So I would like to talk about managing water, energy, food biodiversity nexus for sustainable development. So I would like to start with a few numbers. We have a lot of challenges worldwide. We still have 1.2 billion people suffering from water scarcity and 1.6 billion people suffering from economic water scarcity. And for food security, a few years ago, I checked over 900 million people went hungry 5 years ago. But when I checked the number last night, over 957 million people go hungry now. So even more people are going hungry. And if we have a look at the energy, currently 759 million people without access to electricity. And if we have a look at the biodiversity, a significant loss in biodiversity was found in almost all the continents, particularly for Latin America and the Caribbean have sustained a loss of 94% since 1975. So we have a lot of challenges for energy, water, food, biodiversity, and particularly in the future, the challenges will be much bigger because we will have more population and we need to provide 60% more food, 80% more energy, and 50% more water. So for the Sustainable Development Goals, those elements are all important. For example, for food, we need to have the no hunger target. For water, we need to have clean water and sanitation. Energy, we have the renewable energy target. And for biodiversity, we have the targets for life below water and life on land. So all these elements are very important to achieve the goals, the SDG, Sustainable Development Goals. A few years ago, many people working on single elements. When I worked on my PhD research, that was more than 10 years ago, I worked on the water food nexus. So from this graph, you can see that the water footprint for each person in China, water footprint has an increasing trend because we are consuming more and more animal products. So the changing food consumption patterns are the main cause for worsening water scarcity in China. But if we compare the situation of China with other countries, our water footprint is still small because in many developed countries, the people, they are consuming more animal products. So their footprints are much higher than China. And if in China we further develop, how about our water footprint? Maybe it will increase continuously. And even we have a lot of water footprint from food, but we have a look at the food losses and waste. 19% of the food we produce is lost in different chains. So this is equivalent to 135 billion cubic meters of water used to produce food not eaten, and 26 million hectares of crop land used in vain. So it's a very big loss, not only for food, but also for water and also for land. And in a very recent paper published by a lot of people from me and from other authors, we found that this percentage is increasing based on the field surveys and the literature data. We found now about 27% of the food produced is lost in different process from our field to fork. So this means more food is lost in the supply chain, and this means that we are losing a lot of land footprint, water footprint, carbon footprint, nutrient footprint. So this will have a big challenge. So the food losses is also a big threat to the sustainable development. And when we worked on the research, a lot of media are very interested in the results. They put the results to the public, and also for the SDG, there is a specific target to have per capita global water waste at the different levels to reduce the food losses. And in China, we also have achieved a lot of progress. And this year, the Chinese lawmakers voted to adopt an anti-food waste law. So this is a big achievement. And this law, the aim is to safeguard the country's food security by reducing the food losses and waste. And talking about the water and energy, in fact, in China now, 70% of the electricity is from the coal-fired power plants. But if we have a look at the coal production in China, the coal production is mainly located in the regions with serious water scarcity. So in the future, when we think about the coal-fired power plants, we need to think about the water issue, the water energy nexus. And also, if we can compare different energy carriers, in fact, the coal, this is the water footprint of coal, and those are the water footprint of different other, we call them renewable energy. And the water footprint of renewable energy is normally higher than the water footprint of coal. So in the future, if we want to use more clean energy, what will happen for the water footprint? So based on the analysis in the future, we try to reduce the consumption of coal, but increase the consumption of renewable energy. This will sharply reduce the carbon footprint and the energy footprint, but this will significantly increase the water footprint. So how to balance the water footprint and the carbon footprint and the energy footprint? This will be a very big challenge, particularly we want to achieve the carbon neutrality. This will be an even bigger challenge for us. So currently, agriculture accounts for 70% of water use and 90% of the water consumption. Food production and its supply chain account for 30% of energy use, and energy production accounts for 15% of the water use. So this means there is a very strong nexus between water, energy, and food. And how about the biodiversity? So this is a study from my PhD student and also with the contribution of IIASA. We found that for a tropical island in Southeast Asia, so in this region, by considering the climate change in the future, probably we can meet the energy demand in the future without considering the biodiversity protection. But when we consider the biodiversity conservation, when we considering the protection of the protected area, then we cannot meet the demand of energy, and this can reduce the share of supply to energy by 40% to 80%. So that means in the future, if we try to conserve our biodiversity, this may give a lot of challenges for the water security, food security, and also the energy security. So a few years ago, I was invited by International Association for Hydrological Sciences to give a review on what energy food nexus. And they asked me what are the scientific challenges and the scientific gaps. In that paper, I mentioned that the data, information, and knowledge gaps, and also the lack of systematic tools. Those are two big issues for the water, energy, food challenges, and also the software platforms. So I'm glad to listen to the recent progress in this direction. So I think in the future, how to think about the water, energy, food biodiversity, the nexus. So I think there is a need to shift knowledge generation from the disciplinary tree model, we call it the solar, one people think a sound. So we need to change this to the interdisciplinary web model. So many people from different backgrounds, we need to work together to generate the sustainability relevant knowledge and the solutions. And also at the same time, we need to consider the multiple stakeholders, the people from different stakeholders. We need to work together from the start of any project and also to generate the information for sustainability and to use the knowledge to be generated to get the solutions. So I think we also need the interdisciplinarity and also system analysis for the water sustainability. So that means we need to say goodbye to solo and to welcome the interdisciplinary web model for sustainability, knowledge generation, and solution generation. So that's all for my presentation. Thank you very much for your attention.
Okay, thank you so much, Professor Liu. And a great talk and about food loss and also trade-off between water, carbon, energy footprint, as well as biodiversity, water, energy nexus. And thank you so much for your nice presentation. And again, that I'd like to ask all audience, if you have a question, comment, please write in the chat box. All right, so I'm very delighted to invite the next panelist, Professor Woo Kwon Lee from Korea University. So Professor Lee, please go ahead when you are ready.
Okay, hello everyone. Good morning and good afternoon. Can you hear me?
Yes, we can hear.
Okay, thank you very much for inviting me to this good system analysis seminar in Asia for land, water, energy, biodiversity nexus. I'm Woo Gyun-Lee, the professor at Korea University, and currently I'm in charge of director of Ojong Resiliency Institute and Sustainable Development Institute at Korea University. And then I'm very interesting in SDGs and water, food, energy nexus with the special temporal data set. I'll introduce the water, food, energy nexus in middle latitude region, and also water, food, energy nexus in South Korea. And then our current ongoing projects, the fair stream of IIASA by Dr. Susan Hengerkop. And then I'll explain about the role of Ojong Resilience Institute at Korea University. First, water, food, energy nexus in middle latitude region. I'll explain what is middle latitude region and why we need to focus on middle latitude region. Middle latitude region can be broadly defined as a horizontal belt between 30 and 45 latitude degree. And average temperature of this area ranges from 10 to 20s, representing dry and semi-dry region. And then about 50% of world population live this area and experiencing water and food shortage driven by extreme climate and environmental conditions. And then main challenge of SDGs in this middle latitude region will be desertification and water food shortage. As you see here in left photos, land cover middle latitude region is comprised mostly arid or semi-arid land due to extreme climate, and bring about desertification still. And also this semi-arid region and desertification bring about water stress on food shortage. That's why we need to consider water, food, ecosystem nexus in middle latitude region. Next, ecologically, the middle latitude region are experiencing land cover, land use conflicts. As you see here, mixed forest and croplands and grassland occupies the same latitudinal ranges. So this bring about land use conflict. So we need to consider sound production and consumption of water and food in terrestrial ecosystem in middle latitude region. Regarding to SDGs 12, middle latitude region is still suffering from a land degradation phase. As you see here, it is researched by Dr. Song in my institute. And then most of middle latitude region, as Central Asia, is suffering from the land degradation phase. So we need to consider balance between economic development and land management. I would like to explain about the Korean Peninsula. Why need to also give our attention to Korean Peninsula? Anthropogenic influence on land degradation is quite noticeable in Korean Peninsula. As you see here, left photos, North Korean land management bring about to degrade the land, so-called drastically different the degraded land. And the South Korea managed the forests well, and we keep the forests as a sustainable status. So we can say that in middle latitude region, as I explained already, there is a differences in horizontal ranges, but in Korean Peninsula, there are still different appears vertical differences in land cover. So academically, it will be very interesting if we compare the vertical differences in Korea and horizontal differences in middle latitude. So, I would like to suggest in middle latitude the kind of activities or the researches, the water for energy nexus as a solution to achieve SDGs at the regional and global level. In middle latitude region, the responsible consumption and production of food, water, bioenergy on land and terrestrial ecosystem could help combat climate change in cities and communities through infrastructure and institution in middle latitude region. For performing these ideas, we need to have collaboration among our the institute, IIASA and Chinese Institute and some institute in Korea. And then I would like to explain or introduce the case studies in Korea. Korean Peninsula and South Korea is covered almost 82% of South Korean land covered the forests and agricultural or cropland. And this the 82% needs high the water supply. And regarding net zero emission of carbon neutrality, Korean government have a plan to increase renewable energy from 15% these days and then 64% in 2030. Then there will be a land use complex between forest and cropland and renewable energy site. So we compared the monetary value between forests in terms of ecosystem service and solar energy. And then if we construct solar energy in forests and cropland, the both benefit from solar power generation recorded a deficit until 2023, but started to make net profits from 2024. And we also analyzed the water storage of forest according to forest management, and then we can come to conclusion that when the forest management scenario was applied, the water shortage was analyzed to be higher than the compared to non-management scenarios. And then we checked also crop productivity changes according to irrigation. And then we found that an increase of irrigation water can be ultimately reduce the agricultural drought in South Korea and also ultimately increase productivity, crop productivity. And then I would like to also introduce our Korean project for fair stream as the NMO or NRF to support our institute to participate in fair stream of IIASA. And then we have a plan 3 years the research, and the first year and second year we'll apply the fair stream for Korean Peninsula, especially whole Korea. And then in second year, we'll find the research site in mid-latitude region. And finally, in third year, we'll apply this fair stream for mid-latitude region. This is our stream. First year application in Korea, and second year and third year we'll expand our the application in South Korea to Korean Peninsula and middle latitude region. Our research steps in Korea University, and by this chance, I would like to thank you, Dr. San Hengakop, to collaborate with us. And then I will, if the situation is come to better, and then IIASA will be open, then I will send one of these research steps to IIASA for working together with the IIASA research group.
We're looking very forward to this.
Thank you very much. And then I'm in charge of director of the Ojong Resilience Institute in Korea University. And we have experience to collaborate with Horizon 2020 consortium called EOPN. And we developed the food, water, biodiversity monitoring approach and risk assessment method based on Earth observation data in middle latitude already. And then we established already middle latitude region network, and then we have shared these ideas and research performances and outcomes with the middle latitude region network experts. With these days, we have still the webinar. Finally, I would like to explain or introduce the role of Ojong Resilience Institute at Korea University. And we have a big grant from National Research Foundation this year for basic ecosystem material science as a basic science institute, almost $1,000 billion for 9 years. So we can focus on basic science in terms of material, ecosystem material science. And then OJRE will focus on the solution-based research in the field of sustainable waste management, water resilience, and climate change resilience, ecosystem sustainability, and SDGs in water, food, energy nexus in regionally, for regional and global solution. Yeah, it's all for my presentation. Thank you very much for your attention.
Right, thank you so much, Professor Lee. That's for a nice talk about mid-latitude region as a linkage between region and the global, as well as a case study in Korea. Thank you so much.
Thank you.
Okay, I'd like to invite fourth panel, the Professor Lau from the University of Delhi. Professor Lau, please go ahead when you are ready.
Good afternoon. Thanks, Professor Makoto, for inviting me for making this presentation. I hope the screen is visible.
Not yet, but I think I'm soon, yeah.
Yeah, I hope so.
Yes, coming. Please go ahead.
Yeah. Okay. So, as a panelist of this meeting, the task that was given to us is basically to discuss about 3 points. That is, how can the Nexus help us identify the robust and comprehensive long-term pathways towards sustainable solutions to jointly meet water, energy, biodiversity, and land demands at the regional and global level. The second question that as a panelist I should be focusing is, what are examples of specific Nexus challenges in the Asia? The third is, how can the Nexus approach deliver insights and tools that improve cross-sectoral policy making and support the achievement of the SDGs? I will focus only on these 3 points and try to justify my presence in this here. So if we look at, as all the other speakers has already elaborated, that the food, energy, water is the main nexus part where we look at the interlinkages and the trade-offs through which all these materials are flowing. When I look at the concepts that as ecologists we are dealing with, material flow analysis and other methodology used to be applied for the understanding how the resources are being shared by a society. But recently I have seen the planetary boundaries framework, which has been applied to look at what is the limits, the global limits of the water, land, and energy use, and all the other natural resources such as the nutrients and biodiversity. I really like this framework, but what is the issue with it? If you look at the projections by 2050, the FAO says that the food production or the supply has to be increased by about 70%, and the World Energy Council projects that we require approximately 100% increase of the energy supply to meet these things. Why it is so? This is mainly because the reduced poverty and increased incomes has motivated the people in growing their demands for the goods and services, and thus has increased the exploitation of the natural resources in everywhere, in the entire globe. And this actually has put a lot of stress on the sustainable development goals, which are to be achieved within the ceiling of the environmental protection and also within the socio-economic floor of the situation. So within these limits, then we have to work out how we are going to look at the approach of the WEF framework so as we could link apart. So my problem is when we try to look at something achieved at watershed level or thing, how can we upscale it to the global scale? So the local to local is possible, but local to global and the present to future, this is where all the problems are coming. We are still looking in terms of making some projections of the future and expecting this is going to be the scenario in the given circumstances. And so these are all hypothetical. And thus, when we look at the WF scenario, the interlinkages are very clearly established by the establishment of the material flow analysis and other modules. But what is the major problem is the linking of how water security could influence the food security or vis-a-vis energy security. And all of these three are how they are related to the landscape diversity or land utilization pattern by the societies and how that is going to influence the biodiversity. So as an ecologist, I know that when the requirement of the resources increases, the anthropogenic societies are going to put more pressure onto the landscape, and thus there is going to be a high degree of fragmentation. And this fragmentation is going to result into reduction of water availability. And also, when you try to maximize one function, that is the food, then you are going to influence the other functions that are available. So you cannot maximize all the functions in any given ecosystem. And this is going to be the major problem. So we have to look at a optimization strategy, and which is not yet fully integrated into this WEF framework. To give some examples, if you look at the global land area, a predominant part of the global land is used as the food and fodder production. So if you look at 75% of agricultural land is only used for the livestock sustenance. And this means that we are putting too much of pressure on putting one type of food production. And if you look at least what is the forest, the forests, though is existing about 30%, they are not natural. Only 10% or less than that is natural. remaining part is plantations, which is once again providing ecosystem services in terms of the timber. So the regulating services are getting affected in terms of the transforming the natural forest into plantation forests. And if you look in terms of the global challenges, aridity, as has been mentioned by earlier speakers, is the biggest challenge. So the water availability across the globe is becoming the biggest challenge, and thus it is going to drive the all other functions. The stress of water availability is going to be the biggest challenge across the globe, and I think WF Nexus is going to look at this as one of the important driver. And water is also driving the amount of the food that is available to the anthropogenic societies. And if you look at how the food security is achieved, then this graph is going to show that the availability, utilization, access, and stability. So access is not yet fully understood in most of the societies because food accessibility inequality is very high in some of these countries where we are looking at, not only stressed by the non-availability of water, but also where the food is produced, it is not accessible to all the members of the society, and thus the sustainable development goals are getting affected. And this is one important thing. If you look at the recent reports, the food security in India has been suddenly came down. It has its number has gone down into the total sequences. When we look in terms of the challenges, as has been elaborated in the 2011 document of WF Nexus, we have seen that the water utilization by various aspects. Then 40% of water is looked for the inhabitants in where the developing countries living in the cities. So the urban growth has been driving a lot of consumption of the water, and thus this is going to be a more stress onto the resources that are going to be available. But when we look at the global level, there are few places where the concentration of irrigation has increased. And the Southeast Asian part, China and the India, these are the places where the irrigated intensity has highly increased. And this is at a cost. Not only the surface water, but also groundwater is being extracted by using a lot of energy. And this is putting additional pressure on not only the water resources, but also onto the energy resources, and thus is creating excessive pressures. And when we look in terms of how we are trying to increase the food so as we can meet the demand, the intensification, extensification, and sustainable intensification. Well, first three parts are the ones which is naturally applied by most of the countries. Now we have to look in terms of how we can move that into the sustainable intensification where optimization could be achieved. And thus the concept of WF with some modifications I consider to be more suitable for achieving the sustainable development goals, where we could look in terms of how do we address the water security, how do we address the energy security, how do we address the food security. If we can address these three issues in terms of the WAF, where the livelihood security is integrated, then we can look at whether we will be able to achieve the sustainable development goals or not. I draw your attention to look in terms of the usable hydropower development and the biodiversity impacts. The higher we try to achieve the usable hydropower potential, the more harm we are creating onto the biodiversity, and thus focusing those countries which are focusing more on developing the hydropower is impacting more of the biodiversity rich areas, and this is a major concern, especially in the developing countries like India. So as we could look in terms of how the sustainable development goals should be integrated in terms of the global to the local level, then this figure itself is going to explain very clearly how the biosphere level should consider the requirements of the society, and society should look in terms of the optimizing the economic growth so as the sustainable development goals are achieved. And the major factors that are affecting this FES nexus is the market-driven economy forces as compared to the developmental state economy factors. I consider the current level of market-driven economy forces is very high as compared to the developmental state economy factors. And to close my arguments, I would say that when, as an ecologist, I look at how the diversity in terms of the species richness, in terms of the managed ecosystems, when I look at the intensive food production is possible only when we look in terms of the single field type and the very low biodiversity rich production systems. Whereas when we want to maintain high diversity, then the slash and burn agriculture and nomadic pastoralism are the ones where the multi-field types and the high biodiversity concentration is possible. There is an array of land use patterns that are integrated within these two scales of the diversity and the land use types, which indicates how we are managing our landscape. When I look at the shifting agriculture, which is considered as the adaptive management, when a farmer disturbs a piece of land, we look at how the regeneration is impacting in terms of the biodiversity coming back. As I could see the mature forest as the reference point, it takes about 12 years of regeneration before a notable biodiversity comes back into the system. And thus, the land fragmentation by human society is one of the important factors which is influencing the biodiversity. This is in terms of the species diversity. We are forgetting about the functional diversity, how the ecosystem functions that are going to be available in such fragmented landscape is going to influence the human society.
Professor Rao, please.
I am closing. This is the last slide. Okay, so when I looked at how these species are distributed in different landscape in the Himalayan systems, where when I looked at the entire elevational gradient and looked at the subsets of each of these gradients, I see that there is not much difference in terms of the diversity that is existing in each of the subset that is at the complementing as the entire elevational gradient, and thus the diversity in terms of how the functional taxonomic groups are going to be. To close my argument, I would say that the Nexus approach certainly is going to be an important approach which could move towards achieving the sustainable development goals, provided that it addresses the issues of the cumulative effects of the economy and other development agendas within the planet's safe operating space as per the planetary boundaries framework. Thank you very much.
Okay, thank you so much, Professor Rao, for your very informative talk. Thank you. All right, so I'd like to invite the next speaker, Dr. Sharif. Sorry, that's Majid Abbaspur from the Sharif University of Technology in Iran. So, lady, please go ahead.
Do you have my slides, please?
Yes, I can see.
Slides. Hello to everyone. Can you see my slides, please?
Yes, we can see.
All right, thank you. First of all, I would like to thank you, Dr. Stewart and Professor Taniguchi for the moderating of this event. And as I would like also to thank you, my colleagues. I'm going to introduce Dr. Aida Ahmadi and Dr. Aghajani that have helped me for this presentation, and also other colleagues that I don't have their name here. However, the topic I want to talk is the challenges of energy, water, land, nexus in Islamic Republic of Iran. I'm going very fast through the numbers and figures, as you already know, concerning the situation that we have concerning the increasing of the carbon dioxide concentration in atmosphere, the temperature increase, the evidence of rapid climate change, which I'm going very quickly. One of the problems that we are facing in Middle East countries, including in Iran, is the sand and dust storms, which is caused from this event of climate change. And you can see some of these pictures from the Middle East area. In concerning the contribution of different sectors to GHG emissions, as you can see in Iran, is mostly concentrated on the part of energy. That means 77%. To be brief, I just want to mention, because I don't think we have enough time for presentation, I'm just going to introduce 4 different models in order to be able to take the actions concerning the problem of the climate change and coping with the problem of the water scarcity and also the energy demand, increasing energy demand. In order to do this, I'm going to just indicate some figures. As you can see here, that Iran GHG emission trend unfortunately have been increased from 2.5% between years 1994 to 2000, and it has increased in an increasing pace from 2000 to 2010. At present time, the total amount of emissions of GHG gases of Iran is about 840 million tons per year. So in the universities and also in the policy making organizations, they are trying to somehow resolve this problem and come with some solutions. For the case of water, we have the same problem. And as you can see here on the map, the case of Iran, we have problems of water scarcity seriously because of all these changes we have because of the climate change issue. As you can see here, Iran is a dry country. The annual rainfall in Iran is 250 millimeters, and only 10% of Iran receives enough rainfall to meet its needs. Of course, we have on the northern part, the amount of rainfall is above 2,000 millimeters, but main part of the middle of Iran and in the southern parts, we have this problem. And the other point is that the population doubles every 2 decades. As a matter of fact, 50% of Iran's water being supplied by groundwater aquifers, and water levels in Iranian aquifers have declined by an average of nearly half of a meter every year over the last 25 years. And this is a fact that the agriculture consumes nearly 90% of all potable water in Iran. This is the reason that I'm saying that we are going to face with, I'm going to introduce several models to cope with this problem. Unfortunately, Iran is in its 4th dry spell in over 50 years. And as you can see here, the last autumn we had the maybe driest over the past 67 years, with precipitation level declining by 53% compared to long-term average. This constant decline in precipitation has continued for over 30 years. Of course, another statistic figure says that the 3 eastern provinces have been hit very hard by the present dryouts, receiving less than 20% of their already totally sufficient rainfall. And you can see here again, especially the regions that we have these stresses, and also this color, the brown ones shows the regions that we have problems. Now, the other point is that the Iran's water withdrawal from the surface water and groundwater capacity, the total capacity of the dams, as you can see here, has increased year by year, and we have some problems in this regard. And this is something. And this is a picture of the Lake Oromia. Lake Oromia, as maybe you know, that is one of the largest salty lake waters in the world. And unfortunately, due to these dryouts, you can see that the area of this lake is decreasing year by year, even though some actions has been taken. In order to make some solutions, the policies and solution of energy, water, land nexus in Iran, there have been some national strategic policies and upstreams, which I'm not going to explain those. They are available on the request, as you can see here. And there are also some extreme laws of Iran in order to deal with this problem of climate change issues and the problem of energy water nexus. For example, this is the law on the association of the government of Iran for the Kyoto Protocol on the United Nations Frame Convention on Climate Change, which Iran has joined to this, and also the Convention of Paris. There are many, upstream laws that trying to deal with this problem. And this also shows the role of different sectors in Iran's mitigation actions, which we call INDC, concerning the agriculture, commercial, and so on. Now, in order, this is also the GHG emission trends. Now, we have tried to develop a model which we have called this the multi-variable periodizing technique, because the mitigation methods and also using the advanced technology in order to reduce the amount of energy use is very important. And using this method, which is the output, it's the last output of this model that we have used, tries to show that what are the priorities for mitigation technologies in different sectors. Maybe this cannot be shown very well here, but you can see some of these techniques for different sectors, such as industrial sector, the residential and commercial sectors, and also for the part of agriculture, and also the power production sector. These are the techniques that we have used in order to prioritize that. And this and we so-call this the technology needs assessment in order to be able to find that which actions should be taken first and in order. And the same technique has been used, the same modeling has been used in order to prioritize the adaptation technologies for in order to make the action plans. And at the present time, we are working on the process of API action plans, that we think this is one of the points that we can have cooperation with IIASA, hopefully, and try to introduce this model as much as we can in order to have this cooperation. This also shows the trends in Iran agricultural production by type of the products. That shows that, as I say, more than 90% of the surface water in Iran is consumed by the agricultural sector. So mitigation plans, or in order to reduce the consumption of water, is one of the very important points that we should make in order to cope with this problem of nexus. The problem scarcity in Iran, as I mentioned, are different. For example, the setting of policies to increase water supply while making little improved consumption efficiency, the development of several hundred thousand illegal water, increase in average temperature and decrease in precipitation, and of particular importance, the definition of the region pattern optimized for water use, the suitability of climate economic profitability. This is one of the important points that it has encouraged us to start to work on this issue. The other point that we think we should work on is the lack of a smart irrigation management. For example, over and under irrigation due to unknown crop irrigation, improper water allocation, and lack of monitoring water use. These are the points, and also the other points such as lack of enough effort to use the advantage of desalination to supply from Persian Gulf, which I'm going to explain some about this too. The present capacity of desalinated water in Iran is about only 500,000 cubic meters per day, while in the Persian Gulf area, some countries are more than 14 or more than that. Of course, there are some environmental concerns that we should really take care of that. According to the 6th 5-year development plan, we were supposed, as a matter of fact, we are at the last year of this 5-year plan. We are supposed to provide 30% of water demand through the desalination systems, which we are not able to meet this demand. And this is one of the problems that we should work on. Now, the difficulties for present water resource management system that we can see here, we have to use lots of flow meters, discharge measurement structures, automatic control gates, weather stations, and etc. So in order to substitute this, we are trying to introduce, and we have introduced another model, which this is called we so-called the Smart Water Resources Management System, which we will be happy to introduce this model too. Using this model, as a matter of fact, the farmer-based, supportive to farmers, enabling rather than replacing, usable by any farmer at all levels, and also available, accessible. This model can use, as a matter of fact, the GIS systems and also satellite images and satellite data. With the development of this model, we think can help for the part of the agricultural systems in Iran.
Professor Aspar, could you please conclude?
Yes, well, I think I had less time than my other colleagues. Well, yes, this is the only point I want to make is that we have also tried to develop 2 other models, because we think in order to be able to monitor this, we should try to introduce 2 other models. One is called I have so-called this the model for circular sustainable index. And there is another model for resiliency, which we have called this the modeling for circular energy resiliency index. This picture that you can see is the plan that we have. This is the southern part of Iran, is called the Chabahar area, that we are planning to use this region in order to bring the desalinated water to the mainland. And in order to save or to have the environmental impact assessment, we are at the present time, we are working at the Sharif University of Technology and also in the Institute for Energy, Water, and Environment of Sharif University Institute. We are working on trying to find the ways and means to model and to find the places which are okay in order to establish and to install this kind of water desalination system. And we are trying to work with regional organizations such as ROCME, the Regional Organization for Protection of Marine Environment, and some national organizations in order to be able to go forward for this type of projects. So we are very happy and glad in order to be able to have this type of cooperation with IIASA in order to go ahead and forward these projects. Thank you very much for your patience.
Okay, thank you so much for Professor Baspor about the current status of Nexus in Iran.